and why should we study it? Statistics is the science of learning from data. Data are usually numbers, but they are not just numbers. Data are numbers with context. The number 10.5, for example, carries no information by itself. But if we hear that a family friend's new baby weighed 10.5 pounds at birth, we congratulate her on a healthy size of the child. The context engaged our knowledge about the world and allows us to make judgment. We know that a baby weighing 10.5 pounds is quite large, and that a human baby is unlikely to weigh 10.5 ounces or 10.5 kilograms. The context makes the number meaningful. In your lifetime, you will be bombarded with data and statistical information. Poll results, television ratings, music sales, gas prices, unemployment rates, medical study outcomes, and standardized test scores are discussed daily in the media. The solid understanding of statistics will ensure to make sound, data-based decisions in your career and everyday life. Statistics is the science of data. The volume of data available to us is overwhelming. For example, the Census Bureau of American Community Survey collected data from 3 million households each year. Astronomers work with data on tens of millions of galaxies. The checkout scanners of Walmart's 65,000 stores in 15 countries records hundreds of millions of transactions every week. In all of these cases, the data are trying to tell us a story about U.S. households, objects in space, or Walmart shoppers. To hear what the data are saying, we need to help them speak by organizing, displaying, summarizing, and asking questions. This is called data analysis. Any set of data contains information about some group of individuals, and individuals are just subjects or objects described by a set of data. Individuals may be people, animals, or things. The characteristics that we measure on each individual are called variables. A variable can take different values for different individuals. Some variables, like gender and grade level, simply place individuals into categories. Others, like age and grade point average, take numerical values for which we do arithmetics. It makes sense to give an average GPA for a group of students, but it does not make sense to give an average gender. So a categorical variable places individuals into one of several groups or categories, while a quantitative variable takes numerical values for which it makes sense to find the average. Not every variable that takes number values is quantitative. For example, a zip code is going to tell you a location where someone lives. It doesn't make sense to find the average zip code, but it does group people by location. Other categorical variables are created by grouping values of quantitative variables into classes. We could classify people in data sets by age groups. So you can say an age group of 0 to 9 or 10 to 19. Those would be categorical and not quantitative. So if we look at an example, the Census at School is an international project that collects data about primary and secondary school students using surveys. Hundreds of thousands of students from Australia, Canada, New Zealand, South Africa, the United Kingdom have taken part in the project since 2000. We used the site's random data selector to choose 10 Canadian students who completed the survey in a recent year. The table below displays the data. So who are the individuals in this data set? The individuals are the 10 different people that were selected at random from this survey. What variables were measured, and we need to identify if each one is categorical or quantitative. And if it is quantitative, we need to identify the variable measured. So the different variables are what province the student lives in. That would be categorical because it's just going to put them in location. The next one is gender. Again, that's either male or female, so that is categorical. Languages spoken. Because this tells us the number of languages spoken, this is quantitative because we can find the average number of languages spoken. What handedness they are would be categorical because they're either left or right. You can't find the average. Their height would be quantitative The measure we're using is centimeters. The wrist circumference would be quantitative, and its quantitative variable would be in millimeters. Preferred communication would just put it in a category, so that is categorical. And the travel time to school is quantitative, and it is measured in minutes. Describe the individual in the highlighted row. So the individual in the highlighted row lives in the province of Ontario. That student is a male student who speaks 3 different languages. He is left-handed. He is 150 centimeters tall. His wrist circumference is 100 millimeters. He prefers internet chat for communication, and it takes him 10 minutes to travel to school. Most data tables follow the format shown in the example. Each row is an individual, and each column is a variable. Sometimes the individuals are also called cases. A variable generally takes values that vary, hence the name variable. Categorical variables sometimes have similar counts in each category and sometimes don't. For instance, we might have expected similar numbers of male and females in the census at school data set, but we aren't surprised to see that more students are right-handed than left-handed. Quantitative variables may take values that are very close together or values that are quite spread out. We call the pattern of variation of a variable its distribution. The distribution of a variable tells us what values the variable takes and how often it takes those values. So when you go to explore data, you need to begin by examining each variable by itself, then move on to study relationships among the variables. The best way to do this is to start with a graph or graphs and then add numerical summaries. Sometimes we are interested in drawing conclusions that go beyond the data at hand. That is the idea of inference. In the census at school example, 7 of the 10 randomly selected Canadian students are right-handed. That is 70% of the sample. Can we conclude that 70% of the population of Canadian students who participated in the census is right-handed? No, we cannot. If another random sample of 10 students were selected, the percent who are right-handed would probably not be exactly 70%. So let's check our understanding. Jake is a car buff who wants to find out more about the vehicles that students at his school drive. He gets permission to go to the student parking lot and record some data. Later, he does some research about each model of car on the internet. Finally, Jake makes a spreadsheet that includes each car's model, year, color, number of cylinders, gas mileage, weight, and whether it has a navigation system. So who are the individuals in Jake's study? The individuals in the study would be the cars in the parking lot. What variables did Jake measure? And then we need to identify if each one is categorized